Alright, so in this tutorial we will do some shape drawings. We will finally render some shapes out to the canvas that we have set up. So the first thing you'll do is go to NetBeans. Now the file we've worked on so far, the graphics basic, as I said, this is just going to be a base project that you're going to copy and customize as necessary for your OpenGL work. So what we're going to do is right click on that and select copy, and NetBeans is going to prompt you for a new name to copy the project to. So we will call this graphics 2D because we'll be doing two-dimensional shapes for now, and we'll select copy. So you'll see the entire project got copied into a new project which is called graphics 2D, and your libraries and everything are in place. So for now you can temporarily close graphics basic. Right, so this is our file. To just test that it's working, we hit run and everything comes up as normal. Now in order to render two-dimensional shapes onto the canvas, we'll need to program two shaders, two very simple shaders, the vertex shader and the fragment shader. So we'll first create a folder for that. So what you're going to do is click on Files in NetBeans and right click on the project and say New, and you go down to Other, and we're already creating a folder at this point. Select Other again, scroll along on the right and select Folder. If you like, you can do this through the file system, it's probably faster. And the name of the folder will be Shaders. This is where we will write our GLSL code and then hit finish on that. So back to our project now. So we're going to create a GLSL file now. So right click on graphics, say new, and then select GLSL. If you don't see GLSL on the list, search through the other options and it should be there in one of the lists. So select GLSL, and they're going to ask you for the name of the GLSL file. So for now we're calling it vertex underscore shader, and the folder we'll put this in when we hit browse is going to be in our shaders folder. So we'll select that as the folder and then say finish. Now what you see here is the plugin that we installed since the first video at work. So now it's giving us the syntax highlighting and so forth. This is all just sample information, so feel free to delete that. And we're going to start writing some shader code. So we'll start off with a version, which is OpenGL 4, and we'll use a layout. We'll specify our layout, and this is to normally help with the bindings. Right, so when you see in, it means it's an input variable. So the vertex shader is going to be interested in the position of the vertex and what color it's going to be. And what it's going to put out is the actual color. So we start with just void main, and this is the start of the shader execution. And we're going to initialize the output color, what it's going to output onto the screen. Make it the same as whatever color is coming in. And then the position, is going to be creating a new vector called vec4, and it's going to take that same vertex position, which is really three sets of coordinates. Yeah, the two-dimensional coordinates, and add them. Yeah, and place them onto the screen. Sorry, and this is it for our vertex shader. Extremely simple shader, but it can get more complex. And then we'll do this one more time to create a very simple fragment shader. So right click on your project, say new, and select GLSL, and we're going to call this shader fragment underscore shader, and the folder we'll put this in is the shaders directory. Then say finish on that. Once again, delete the sample data, and start off with a version. An input variable, which is going to take the color. The output is the fragment color, which is, it's going to interpolate the color of each pixel within the vertices specified. Let's see, void main color, that color is equal to vec4 color 1.0. The last parameter there specifies the alpha color. And that is it for our fragment shader. And we'll now go into the renderer class, and we'll go into the init method. So render class, and we're interested now in the init method. Now this method is called initially before any drawing is done to the screen. So the first thing we're going to do here is to create shader objects, and here is where you're going to find that the code we spent time writing is going to make our jobs a lot easier. So the vertex shader is going to be shader handler dot create shader, and the path we're going to pass this is shaders slash vertex underscore shader dot glsl, and the type of shader we're creating, gl4 dot gl underscore vertex shader. Right? So our method there did all that work of creating the shader, ensuring it was found and all that stuff. The same thing we're going to do for the fragment shader, which is going to be shader handler dot create shader. You specify the path shader slash fragment underscore shader dot glsl, and the type of shader we're creating is a fragment shader, gl4 gl underscore fragment shader. Right, so we've created our shader. The next thing we're going to do, we're going to put these shaders in a list. Vertex shader and the fragment shader. I think I spelled it wrong here. Yeah, the vertex shader and the fragment shader. And what we're going to do is we're going to get a handle to the program, which is going to be our shading program. So we're going to create this program using the shader list and an instance of the GL context, the current instance of the GL context. So again, we're using the methods we defined previously to just really quickly go through these initial steps. Yeah, so the next thing we need to do is to set up our vertex and index positions. And the color index. Right, now if you would have noticed when we set up the vertex shader, we actually did use a layout and say the location of the vertex position is position 0 and the location of the vertex color is in position 1. So this is the way you essentially are going to do the binding of the vertex position, which is going to hold it as the position information and the vertex color. So this is how you bind those to those two variables within the shader, because if you look at it, these two variables, as I said, they're in variables, so they're looking for information coming in. So since there is no real direct linkage between what we're writing in OpenGL right now and the shader we would have loaded and compiled, this is just a way of saying that what we specify on the outside as position 0 when it's running, link it to this vertex position, position 0, and what we specify as the color in position 1, link it to the vertex color. So this stuff is what we're going to pass when we're actually going to set up our buffers now. Right now we are going to get back to this method in a few minutes. We need to do a few things first. First of all, we need to set up, since we're going to be drawing some two-dimensional shapes, what I'd like to go ahead and do is actually set up that package. So you'll say new Java package, you call it shapes, and then you go ahead and hit finish on that. Now within the shapes package, you're going to create a class called shape. And this shape is going to be an abstract class. So we're going to have two abstract methods. Get position data, get color data. Right. And then within the shapes package, we're going to create another Java class, which we're going to call triangle. And this triangle class is going to extend the shape class. And obviously, since the shape class is abstract and it has two abstract methods, we're going to need to provide the concrete implementations of these methods. So we need to set up two arrays. One array to hold the position data and another array to hold the color information. So we're going to set up the position data, which is really the vertex data, stating where the vertex are located on screen. And OpenGL usually is clamped within the range -1 and +1 on every axis, X, Y, and Z, but we're currently only dealing with the X and Y. So 0.8 that is the x position, to negative 0.8 f is the y position, and we're always going to be 0.0 f on the z because we are not doing three-dimensional yet. So 0.8 f on the x, negative 0.8 f on the y, and as always 0.0 f on the z. You can graph this and see that it does form a triangle. 0.8 f, then 0.0 f. To see that it does form a triangle on some graph paper. And the color data is going to be follows the same RGB color scheme, and again this goes up to from 0 to 1, so 0.5 is going to be like half the color, 1 is going to be the brightest the color can be. So this is an RGB color scheme, so 1 means make it entirely red, no blue, no green. The other one we're going to do is no red, all green, and no blue. Finally, no red, no blue, no green, sorry, and all blue. Right, so these are two arrays. So we'll return the position data. For the get position, and we're going to return not get color data, but color data. It's not color data. Great. And that is it for our triangle. That's it for our triangle. So we're going to head back over into our render class, and there is one thing we need to do. We need to set up a global variable so that our display method will know the vertex array handles for our triangle, which means it'll know where the color and position data is set up. So, private int this is just going to be size 1. So finally, back in our init method is where we're going to continue. And after we specify the vertex position index and the vertex color index, back in the init method, we're going to create first create a new triangle. And we'll go ahead and make it import. And now we'll have our buffer handler. That setup buffers. It automatically takes the triangle VAO handle that we would have specified earlier, so it's going to store the column position data in there. And for the position data, we'll say triangle dot get position data, and for the color data, we'll say triangle dot get color data. And the two indices we need to pass is the vertex position index and the vertex color index. And this will go ahead and set up all our buffers and return a handle to the triangle, or set the handle to the triangle. So the final step which we need to do is say shader handler link the program handle, and we pass it a reference to the current GL context. And then finally, after we've linked the program, we need to use the program. So use program, and we say the program handle. We pass the program handle to it. Great. So now we're using the program we compiled with our triangle and triangle position and color data. So the last stuff we need to do is within our display method. So within the display method, the first thing we need to do is clear the current buffer, and this will clear the screen to black, the drawable area to black. So gl.gl clear gl4 clear the buffer bit, clear the screen to black, and then we need to bind the vertex array, and we'll pass the triangle VAO handle at position 0, which is going to hold all our triangle information. And then we tell OpenGL to draw the array, and the mode we're going to use is triangles. So we're telling it to draw triangles. We're telling it to draw from the very first vertex, and we're saying that there are 3 vertices to draw. And when we're finished, we finally say flush. This ensures that the completed rendering gets pushed onto the screen. So hopefully at this point we should be able to select run and see a color triangle on the screen. So let's try that. And there we have it. We see a color triangle on the screen. Alright, so I made a slight mistake in one of the vertex position information, and that is here for the triangle. This is not supposed to be 0.8 but 0.0. So if you save that and you run the program again, you should see the triangle looking like this now, which is what I expected it to look like at first. So now you know how to actually get two-dimensional shape onto the screen, and you can see when it's resized, the shape resizes automatically. So you don't necessarily need to do anything in the reshape function as yet. So there's one last thing I'd like to show you, and that is to we'll create one more shape for an example. And we'll create a new Java class, and we'll call this square. And we'll finish on that. And again, this is going to extend the shape class, and we're going to implement those methods. So once more, I'm going to provide the position and color data for the shape. The square, sorry. And since this is a square, we'll need 4 vertices. Minus 0.5 F. Alright, so that's the position data. Now for the color data. And if I didn't mention it before, when you specify color information, it's not the color for the entire object that you're drawing, but it's really a color for the vertex. The fragment shader is going to interpolate the colors from each vertex, and that is how, because you specify a different color for each triangle vertex previously, that is how the triangle at the vertices held the solid color, but as it approached the middle, the fragment shader interpolated the colors, so that's why they kind of blended and look different. So we'll say red. And the last one, obviously, making it white. So here in the get position data, you see return this dot position data, and in the get color data, you'll return this dot color data. So here's where we'll go back to the render class, sorry, and just before we link and use the program, we can specify another primitive to draw. And here we'll say square, to new square, and go ahead and add that import. And once again, we'll also need a handle for the square object that we're drawing, so at the top of the file we declare that. Yeah, we declare that, and here we make a similar call once more. So if we did not write this method to set up the buffers, we would have to essentially copy and paste the entire code again. So it takes a square VAO handle, and we're going to say square dot get position data, square dot get color data, then vertex position index and vertex color index. Alright, so in the display method, we once again, after we clear the color buff a bit, before we flush, we need to bind the vertex array, and in this case it is the square VAO handle we've created. So we need to draw the array, and this mode is GL4 GL underscore the triangle fan. The first is at position 0, and the amount of vertices we're specifying are 4. So hopefully now we should see that square up here. And there's the square that we have created. I know it doesn't look as like a perfect square, but why that is so is that you need to remember that we set our window size to be 640 by 480, which is not a perfect square, and as a result of that, the image is a bit skewed and stretched. But if you were to try to adjust it, you would see it. If you try to adjust the window to a perfect square, you would see it approaching that. But this is how you do simple two-dimensional images on the screen. So I would urge you to play around and get used to the coordinate and color system.